Hello student, I am Dr.A.K. Today I am going to discuss hydrides. Last class I have discussed hydrogen. Now I am going to discuss hydrides. Hydrides means that here hydrogen will be in the form of anion H minus. Dihydrogen means H2. Under certain reaction conditions combine with almost all elements except noble gases to form binary compounds called hydrides. Here hydrides are of three types. If E is the symbol of an element, then hydride can be expressed as EH2. E is the symbol of an element, then hydride can be expressed as EH2. As for example, now MgH2, magnesium hydride. Okay. The hydrides are classified into three categories. First, ionic or saline or salt-like hydride. This is the first category. Second category, covalent or molecular hydride. Third category, metallic or non-stoichiometric hydride. Before going to these details, here I want to tell you that B2H6 boron hydride, this is very popular in hydride, boron hydride B2H6. Actually boron hydride BH3, but boron is you know that it is a electron deficient, hence it will dimerize and it will give B2H6. Okay, magnesium hydride, calcium hydride, potassium hydride, sodium hydride, these are the general examples of hydride. Now I am going in details. Ionic or saline or salt-like hydride. Okay, first I will discuss this. These are stoichiometric compounds of dihydrogen formed with most of the S block elements, which are highly electropositive in character. However, significant covalent character is found in the higher metal hydride such as lithium hydride, beryllium hydride and magnesium hydride. In fact, beryllium hydride and magnesium hydride are polymeric in structure. The ionic hydrides are crystalline, non-volatile and non-conducting solid. Okay, the ionic hydride are crystalline, non-volatile and non-hydrides. These are crystalline, and what I told, these are the main characteristic. The ionic hydrides are crystalline first, second non-volatile and third non-conducting in solid state. However, their melts, means in melting condition, their melts conduct electricity and on electrolysis liberate dihydrogen gas at anode, which confirm the existence of H minus ion or hydrogen ion, you can tell. Then here reaction will take place like this: 2H minus. 2H minus in melt. At anode it will give H2 plus 2 electron. It will liberate 2 electron. Okay. Actually melts conduct electricity. Why they are conducting electricity? Now you are understanding, because it liberates electron. 2 electron it will liberate. Their melts conduct electricity and on electrolysis liberate dihydrogen gas at anode, which confirm the existence of hydrogen. Okay. Hydrogen ion negative, it means hydrogen ion can tell hydrogen ion. Then 2H, that at anode it will convert to H2 plus 2E. Saline hydride react violently with water. This is very important. Saline hydride react violently with water, producing H2 gas. Reaction is like this: NaH. NaH, sodium hydride, is solid. NaH plus H2O. H2O is liquid. If both will react, it will form NaOH, sodium hydroxide plus hydrogen gas. Okay, NaH plus H2O, it gives NaOH plus H2. Lithium hydride is rather unreactive at moderate temperature with O2 or Cl2. It is therefore used in the synthesis of other useful hydrides. Okay, examples: 8 lithium hydride plus Al2Cl6. Here actually Al2Cl6, AlCl3 is there, but it will dimerize. It is also electron deficient. AlCl3, it will dimerize, then it will give Al2Cl6. Then this aluminum chloride reacts with lithium hydride, means 8 LiH, balanced equation, 8 LiH plus Al2Cl6. It gives lithium aluminum hydride, LiAlH4 plus 6 LiCl. This is the balanced reaction. Again I am telling you, 8 LiH plus Al2Cl6, it gives 2 Li, 2 lithium aluminum hydride, 2 LiAlH4 is important reaction. 2 LiAlH4 plus 6 LiCl. And again 2 lithium hydride, balanced equation, 2 lithium hydride plus B2H6, it gives lithium boron hydride. Again this reaction is very important. Again I am telling you, 2 lithium hydride LiH plus B2H6, it gives 2 LiBH4. Okay, lithium boron hydride. This I have discussed about the ionic or saline hydride. Ionic means, simply know that this hydride exists in the form of ion. That's why it is called ionic or saline hydride. Now I am discussing second type of hydride, covalent or molecular hydride. Dihydrogen forms, dihydrogen means hydrogen gas, forms molecular compounds with most of the p block elements. With p block elements, covalent or molecular hydride is formed. Most familiar examples are CH4 means methane, NH3, H2O and HF, hydrogen fluoride. For convenience, hydrogen compounds of non-metals have also been considered as hydride. Being covalent, they are volatile compounds. These are volatile compounds. Okay, particularly these non-metals. Non-metals have also been considered as hydride. Being covalent, they are volatile compounds. Molecular hydrogens are further classified according to the relative number of electrons and bonds in their Lewis structure. Actually, it is classified, molecular hydrides are classified into three categories. First, electron deficient. Second, electron precise. And third, electron rich hydrides. An electron deficient hydride, as the name suggests, has too few electrons, means very less. Too few electrons for writing its conventional Lewis structure. Lewis structure, you know that 8 electron is full for the stability, 8 electron is required. Okay. Then diboron, that is a B2H6, is an example of electron deficient hydride. Example of electron deficient hydride question is asked. Okay, then it is B2H6. This is an example of electron deficient. Now, other example I am telling you. All elements of group 13 will form electron deficient compounds. What do you expect from their behavior? Why 13 group 13 will form electron deficient compounds? Because they act as Lewis acids, electron acceptors, because they are electron acceptor. Okay, they act as Lewis acids. Okay, now come to the second, electron preciser. Electron precise compounds have the required number of electrons to write their conventional Lewis structure. Here, electron precise means they have complete electrons to write the Lewis structure. But first one was having less electron. That electron was not sufficient to write Lewis structure. But here, in electron precise compounds have the required number of electrons to write their conventional Lewis structure. All elements of group 14 form such compounds. As for example, methane. Methane is common CH4, which are tetrahedral in geometry. Now, third one, electron-rich hydride. By name itself it is clear. Electron-rich hydride have excess electron which are present as lone pair of electrons. You know that in NH3, in H2O, in PCF, in phosphorus compound, they have extra lone pair of electron. Okay, extra electron they have. Then they have you can say lone pairs. Elements of group 15 to 17 means 15, 16, 17 form such compounds. Electron-rich hydride who will make then 15 to 17 group means 15th, 16th, 17th form such compounds. As for example, NH3 has one lone pair. Now in NH3 nitrogen has one lone pair, and H2O, in H2O oxygen has two lone pair, and HF means hydrogen fluoride has three lone pair. Okay, what do you expect from the behavior of such compounds? Then you understand. They will behave as Lewis bases, that is the electron donor, because they have lone pair and they can donate. Hence these means 15, 16, 17 groups elements can behave as electron donor, means base, Lewis base. The presence of lone pairs on highly electropositive atoms like N, O and F in hydrides result in hydrogen bond formation. Again you listen carefully. The presence of lone pairs on highly electronegative atoms like nitrogen, oxygen, fluorine in hydrides result in hydrogen bond formation between the molecules, and due to this leads to the association of molecules. Now I am going to discuss third categories of hydrides, that is called metallic hydride, also called non-stoichiometric hydride. Okay, this is the third category. These are formed by many D block and F block elements. Here I want again, I am telling you, I am reminding you that these three categories what I told. Then first category, that was forming due to the S block elements. S block elements means ionic or saline or salt-like hydride was formed by S block, and second hydride, that is the covalent or molecular hydride, that was formed by these things 13 group 13. Okay, and now this means group 13 means P block elements are forming a covalent or molecular hydride, and this metallic or non-stoichiometric hydride is formed by D and F block elements. Okay, these are formed by many D block and F block elements. However, the metals of group 7, 8 and 9 do not form hydride. Okay, metals of group 7, 8 and 9 do not form hydride. Even from group 6 only chromium forms hydride, and its name is chromium hydride, CRH. This is exception and important for examination. Okay, 6 group also only chromium forms. 7, 8, 9 that I told you do not form hydride. Even 6 only chromium forms hydride, that is the CRH, chromium hydride. Okay, these hydrides conduct heat and electricity. Though not actually these hydrides conduct heat and electricity, though not as efficiently as their parent metals. Parents metal, they will conduct more, but these hydrides are not conducting as much. Unlike saline hydrides, not like, unlike saline hydrides, they are almost always non-stoichiometric. Okay, these hydrides are almost and always non-stoichiometric, being deficient in hydrogen. Here stoichiometric means they lack hydrogen, they don't have sufficient hydrogen. Okay, then always they form non-stoichiometric hydride, being deficient in hydrogen. For example, lanthanum hydride, LaH. Here you will write hydrogen not in whole number, you will find in fraction 2.87, like that way, lanthanum hydride. Second, yttrium, YB, yttrium. Okay, one is yttrium, Y, this is YV, yttrium, B, YB. Here hydrogen is H is 2.55, not whole number, fraction. YB, H, and H, how many H? 2.55. Like that titanium, you will find H 1.5, between 1.5 to 1.8. Variation is there. Titanium hydride, TiH. Here number of H is 1.5, between 1.5 to 1.8. Other, that is the zirconium hydride, ZrH. Here hydrogen is between 1.3 to 1.75. Next example is vanadium hydride. It has very less, number of hydrogen is 0.56. Next is the nickel hydride. Its again hydrogen is less, 0.6 to 0.7. Next is palladium hydride, PDH. H is between 0.6 to 0.8. Then in question is asked, then by seeing the fraction you can tell this is the stoichiometric, non-stoichiometric hydride. Okay, non-stoichiometric hydride or metallic hydride. By metal you can understand chromium, nickel, vanadium, palladium, zirconium. By C you can understand. And non-stoichiometry means now you have seen that their hydrogen is lacking, lacking, deficient in hydrogen. That's why it is called non-stoichiometric, or also called interstitial hydride. Earlier it was thought that these hydrides, hydrogen occupies interstices in the metal lattice, producing distortion without any change in its type. Consequently, they were termed as interstitial hydride. However, recent studies have shown that except for hydrides of nickel, palladium, cerium, and actinium. Actinium means AC. AC means actinium. Cerium means Ce. Palladium means Pd. Okay. Then this was considered as a interstitial hydrides, but recent studies have shown that except for hydrides of nickel, palladium, cerium, and actinium, other hydrides of this class have lattice deficient. They have lattice deficient except this what I told you, nickel, palladium, cerium and actinium. These are actually interstitial hydride. Question will be asked. These they will form interstitial hydride, nickel, palladium, cerium and actinium. And other hydrides of this class have lattice different from that of the parent metal. The property of absorption of hydrogen on transition metal is widely used in catalytic reduction or hydrogenation reaction for the preparation of large number of compounds. Okay, this again you listen, this property of absorption of hydrogen. The property of absorption of hydrogen on transition metals is widely used in catalytic reduction or hydrogenation reaction for the preparation of large number of compounds. Some of the metals like palladium, platinum can accommodate a very large number of hydrogen. Okay, palladium, platinum can accommodate a very large number of hydrogen and therefore can be used as its storage media. You can tell as a storage media because they can absorb more hydrogen. This property has highly potential. This property has high potential for hydrogen storage and as a source of energy. Here this is important again. Here many question is asked only from what I am teaching you now, that these metals palladium and palladium PD and PT they have high potential for hydrogen storage, and hydrogen gives large quantity of heat or energy. Okay, then this property has means storage property. This property has high potential for hydrogen and as a source of energy. Okay, now I have discussed about the hydride. Okay, now actually this small questions are there, problem that is asked in examination. I am going to discuss that things. What is actually problem? Then problem is that actually it is for advanced or means also, even in medical. This question is asked. Would you expect the hydrides of nitrogen, oxygen and fluorine to have lower boiling points than the hydrides of their subsequent group member? Give reason. This is the question. Again I am reading. Would you expect the hydrides of N, O and F to have lower boiling points than hydrides of their subsequent group members? Give reason. This is the question. Okay, this type of question is asked in examination. Then now I am telling explanation. Okay, on the basis of molecular masses of NH3, H2O and HF, their boiling points are expected to be lower than those of the subsequent group members hydrides. However, due to higher electronegativity of nitrogen, oxygen and fluorine, the magnitude of hydrogen bonding in their hydrides will be quite appreciable. Hence the boiling points of NH3, H2O and HF will be higher than the hydrides of their subsequent group members. Because of hydrogen bonding, their boiling point will be, they will have more boiling points. But if they will be only in H2O form, HF form, NH3 form, means molecular form, then it is less. But you know that NH is N, O, F, they are electronegative. Hence, they will, I can say, form hydrogen bonding. So many NH3 can join with itself and it will form liquid. It is a gas. NH3 is a gas, ammonia gas. But it can form liquid you can say, ammonia also. Then they can, hydrogen bonding is possible in all three compound. In H2O already you know that hydrogen bonding is there. Otherwise H2O will be gas. But due to the hydrogen bonding it is a liquid. And HF also same type. HF is gas. But due to the many HF, it can convert into the liquid also. Now I am going to just tell other you can say problem. Okay, other problem also I will tell. Now this again question is there, problem is just to listen. Can phosphorus with outer electronic configuration 3s square 3p5 form pH5? This is a question that can phosphorus with outer electronic configuration 3s square 3p3 not 3p5 3p3 phosphorus belongs this 3s square 3p3, this is the electronic configuration. Will it form pH5? Because total 5 electrons are there in electronic configuration, 3s square 3p3, then 3s square and 3p3, total 5 electrons, 2 plus 3 5. Then question is that can phosphorus with outer electronic configuration 3s square 3p3 form pH5? This is the question. Now I am explaining, I am giving explanation. Although phosphorus exhibits +3 and +5 oxidation states, phosphorus exhibits or have, you can tell, although phosphorus exhibits +3 and +5 oxidation states, it cannot form pH5. It can't form pH5. Besides some other consideration, high, you can say, heat of formation value of dihydrogen and this, that is the heat of formation, that delta HF I am talking about, value of hydrogen do not favor to exhibit the highest oxidation state of P, phosphorus, okay, and consequently the formation of pH5. Actually hydrogen know that it's a it will not broken easily. It requires, I can say, breaking ionization energy is very high, dissociation energy is very high for hydrogen. Then it is difficult it is difficult to break the, you can say, bond between H and H, first things. Okay, and for this high delta H value of dihydrogen, and this hydrogen, mainly hydrogen, there these things energy, bond energy is required, more heat is required. Okay, that's why this will not break easily. High, you can say, this delta H value, is very high, and due to this it will not favor to oxidize the highest oxidation state of phosphorus. Means hydrogen can oxidize phosphorus, it can oxidize, but due to, you can say, it requires more energy, because phosphorus, we can say, both 5 electrons are there, that is the 3s2, 3p5. Then it is very difficult to remove 3p3 is possible. 3p3 is possible because it is outermost, but 3s2, it requires very high energy, that is not given by the, you can say, hydrogen, not sufficient. That's why it can't form the this pH5. Okay. Now I am going to discuss, you can say, very important topic, that is the water. Water is very important. Okay, from every point of view, by knowledge point of view also, by examination point of view also, from many point of view, we should know about the water. In our body, roughly 70 to 75% water is there. It is variable, sometimes maybe 71%, 72%. Okay, then in our body 70 to 75%, okay, water is there. If our body, our weight is 60 kg, then 42 kg is water. Rest are other things. See, water importance in every trees, plant, okay, everywhere water is there. Now I will tell you water content, but wherever greenery is there, particularly plant, trees, everywhere in there, if you see their structure, constitution of the plant and trees, you will find water is there. Even in our blood also, water is there in our blood. Okay, then water is very important. In animals body also, same ratio, 70% ratio you will find 70-71% everywhere which is existing, any life is existing, roughly 70 to 75% water will be there. Elephant, you can see how much water it is drinking. Okay, all animals, even the insect also, but their quantity of water will be less. Okay, all type of animals, they want water also. Dogs, you see how much water they are taking. Every life, the water is very important for us. And what is its main reason? Then you know that actually we eat food. After eating, we require water. Why we require water after taking food? This is a very important question. Actually, this after chewing our food, it is going inside, but it will fill the pipe, food pipe. It can't go further down. Then for one purpose, that if you will drink water, it will go down, then further you can eat. This is the simple reason. But the main reason is that after chewing food will become a small and very small pieces, very small pieces. But now we know that all reaction takes place in a solution form, Then if we will not drink water, then how reaction will take place? Our life is full of chemical reaction. In our body, full of chemical reaction. Okay? Everywhere, in plant also, animals also, everywhere full reaction, chemical reaction in our body. And all food is actually, you can say, chemicals for us, also called fuel, chemical fuel or biological fuel. Then these require solvent to dissolve it, and that's why water is a universal solvent. You drink in sufficient quantity that it will dissolve, all food will dissolve, then all will be separated. Many things we are eating in the form of protein, fat, carbohydrate, correct, vitamins, then now all will dissolve. They will come in the form of molecular form or atomic form. Then they will again react in the solution, means in water, and many things it will form as a product. That's why in our body require more water. Then roughly 70 to 75% water is sufficient. Then how I told you the same situation is everywhere. Then you can understand the importance of water. Many uses are there of water. Okay. A major part of all living organism is made up of water. No water, no life. A major part of all living organisms is made up of water. Human body has about, can say, already told you, 70% water. It may sometimes it will be less also, like 65% also. Then variation is there, but generally 70% you can tell. Little more than 70, less than 70%. Okay. Then human body has about 70%, or you can say 65 to 70%. 70 variation is there. It is not 100% fixed. And some plants have as much as 95% of water. Plants have 95% of water. Now you can understand. It is a crucial compound for the survival of all life forms. It is a solvent of great importance. Actually, in human body, water variation is there, 65% minimum it is required. Okay, 65%, but it may vary to 70%. Okay, more than that. But maximum limit I told you, go be 72, 73, like that. In rare case, 75 also. Then now I have told you that quantity of water present in, you can say, living substance, and in plants it will go up to 95% of water. It is a crucial compound for the survival of all life forms. It is a solvent of great importance. The distribution of water over the earth's surface is not uniform. Now I am telling you estimated world water supply. Okay, in whole world, how much water is distributed, where you will get more or less water, that is estimated, I am telling you. Then maximum water, that is the 97.33% out of 100%, 97.33% water is available in ocean. See, maximum water 97.33. And saline lake, in a lake also water will be there, but lakes are very less. Lakes are inland seas. sea, what is SEA, seas, their water is less. Less means 0.008%. Okay. Polar ice and glaciers. Polar ice and glacier, there it is roughly 2.04%. 2.04%, very less. Okay. But in sea, it is very less, 0.008. Here at least in polar and glacier, 2.0% water is there. Groundwater is 0.61, less than polar. Okay. And lake, only lake. A lake is two types, saline lake and this fresh lake, which water, that water you can drink. Saline lake you can't drink because more salty water. Actually, ocean water is 97.33, but it is useless. Useless in the sense you can't drink. So saline, so salty, you can't, nobody can drink. Okay, but nowadays they are trying to make it soft, very hard water. Okay, salt is maximum in this water. That's why it is not used. It is used in a indirect way. Okay, then lake, some lake's water you can drink, then that is a 0.009%. Okay, less than groundwater. In lake it is a 0.009%. Our soil, our earth, our soil also, soil have moisture, and its quantity is 0.005%, very less, 0.005%. And even in atmosphere also has water vapor, but it is very less, 0.001. Okay. And rivers, ordinary rivers, look, that is a big river, but in the sense of how much water, then it is a very less, that is a 0.0001330. Okay. And here only you can know that drinking water everywhere, drinking water nowhere. This proverb is there. Then drink, I told water is everywhere, 97.33, but what is of use? Drinking water nowhere. Water everywhere, drinking water nowhere. In standard 1, standard 2, you might have studied. Then 0.03% water only is available for drinking. So less, 0.03% water is available for us for drinking purpose. That also, it is not, you can't get freely. It is locked up. In glacier and other thing, it is locked up. Then it is difficult. It is expected by 2000, actually, when this is older this thing data, by 2030, that water scarcity will be there in whole world. In whole world, water scarcity will be there, drinking water. Hence, we should think for how to conserve the drinking water, soft water, fresh water. Okay. Then now I am going to tell this thing, physical properties of water. It is a physical properties of water I am talking about. It is a colorless. You already have seen the water. So many things you already are knowing. It is a colorless and tasteless liquid. its physical properties are, already I have told you physical properties. Okay. Now heavy water, do you know? Heavy water, that is the D2O, just like H2O. It will be D, capital D, D2O. In the place of H2O, in the place of H, you write D, D2O, that is the heavy water. Okay, but it is very less, very less. Okay. The unusual properties of water. Now understand interesting property of water. The unusual properties of water in the condensed phase. In condensed phase fluid, condensed phase liquid content, liquid and solid states are due to presence of extensive hydrogen bonding. Why we get water? Thanks to hydrogen bonding. Otherwise, we would have not got water on earth. Because only H2O means vapor or gas, you can tell it will go to the atmosphere. But due to the hydrogen bonding, it became heavy. All H2O joined to each other by hydrogen bonding. Now its molecular mass became very high due to hydrogen bonding, heavy. Then they can't fly, they can't go to the atmosphere, they can't evaporate. Okay, that's why water exists on earth. These are unusual properties. The unusual properties of water in the condensed phase, that is the liquid or solid state means ice, are due to the presence of extensive hydrogen bonding between water molecules. This leads to high freezing point, high boiling point, high heat of vaporization and high heat of fusion in comparison to H2S and H2SE, selenium, hydrogen sulfide and hydrogen selenium, oxygen, sulfur and selenium all belong to the same group. Question is asked also in examination. Oxygen, sulfur and selenium belong to the same group, but H2O is existing. H2O is existing on the earth. We are getting water, but we are not getting, you can say, liquid H2S or liquid. Just like water, we don't get H2S and H2SE, selenium. Selenium is, you can know, is poisonous. Okay. Then, just like H2O, there should be also these things, ocean, lake, river, should be, but it is not like that. Why? This question is asked. Despite oxygen, sulfur and selenium belong to the same group, there is no ocean, there is no river, there is no lack of this H2S and H2CSE, selenium, hydrogen selenium. Why? Because they don't make hydrogen bonding, because they are very, very less electronegative in comparison to the oxygen. Oxygen is very, very reactive, very, very reactive. That's why it is forming hydrogen bonding. Okay, and these sulfur and selenium have you can say they are less electronegative. Then you will ask the question, what for the fluoride? Fluoride is most electronegative, fluoride. But you know that fluorine is found in very, very less quantity, very, very less quantity. Okay. And already it is found, it is in less quantity, and it is whatever available was there in the beginning, it combined. That's why they can't make like this. But hydrogen and oxygen are found in more quantity. Then now I have told you about these things. This question is asked. In comparison to other liquids, water has a higher specific heat, thermal conductivity, surface tension, dipole moment, and dielectric constant. Okay, this is a special case of this. In water has a special property, okay, that in comparison to other liquids, water has higher specific heat. It will not become can say hot quickly, and it will not become cold quickly. It takes time in becoming warm, and it takes time to becoming cold due to the high specific heat. Thermal conductivity is also, we can say, less. Okay, thermal conductivity. Surface tension. Water has this type of special quality. Water has higher specific heat, thermal conductivity, surface tension. Actually, thermal conductivity in comparison to the other liquid, it is more. From the water, current can be passed because H ion and OH ion is there. It is not fully ionized, feebly ionized water. That's why a small quantity is ionized. Then heat can be passed. It can conduct the heat and electricity. From the water, current also comes, but it will be light, less. And dielectric constant value is there. That's why due to the high dielectric constant value around 80, 79.9, many things it will dissolve in it. Many things can be dissolved, or water dissolves many things. Surface tension is also high. Now dipole moment is also high in comparison to the other liquid. And these properties allow water to play a key role in the biosphere. Biosphere means atmosphere, you can say, where organisms are found. That's why bio word is used. Bio, actually, everywhere chemical reaction is there, everywhere in real sense. But if you talk about the, you can say, body, human body, animal body, plant body, means inside, then you have to add a term bio. Okay, that is related to the life organism. Otherwise, inside also chemical reactions are there, but chemical reaction inside the body, inside the plant, inside the human being, that is called biochemistry. Biochemistry. It is also chemistry, but general chemistry and biochemistry. Here only a difference is that you are studying chemistry within body, human body or plant body. Okay. The high heat of one more thing, this in ocean, river, you have seen in lake, in summer water will vaporize, because in summer heat will be in comparison to winter winter and rainy season. This sun rays, in summer sun rays have high energy. That's why it can evaporate. H2O bond partially can be broken. Okay, upper layer of water, not everywhere. Upper layer of the ocean will vaporize, not the inside in depth. That's why water vaporizes. Water of ocean also vaporizes, and these rivers, lakes, they will become dry soon, because their water is less, thickness is less, depth is less in comparison to the ocean. Okay, but it vaporizes everywhere. Then this I have told you, the high heat of vaporization and heat capacity are responsible for, you can say, moderation of the climate and body temperature of living beings. Okay, this thing, heat capacity, high heat of evaporation and heat capacity are responsible for moderation of the climate and body temperature of living beings. It is an excellent solvent for transportation of you can say ions and molecules required for plant and animals metabolism. Due to hydrogen bonding with polar molecules, even covalent compounds like alcohol and carbohydrate dissolve in water. Okay, alcohol organic compounds are there, carbohydrate organic compounds are there, but you can say covalent compounds, they are covalent, not ionic. But water you know that is dielectric constant value is more. Then even covalent compounds like alcohol and carbohydrate dissolves in water. Some properties I am telling you which you should know, that is molecular mass. Molecular mass of water you know that is 18 gram. Exact is 18.0151 gram per mole. Okay, water H2O 2 plus 16 18. Then 18 gram per mole is the molecular mass in general, in simple way. Melting point of water, melting point in Kelvin, that is the 273, that is a 0 degree centigrade. 273 plus 25, okay, that is a 298, but here 273, that is a 0 Kelvin. And boiling point you know 100 degree, means 273 plus 100, 373. Okay, and these things here you should also know for the deuterium oxide, heavy water, its molecular mass is more, name itself is heavy water, then its molecular mass is there 20. Ordinary water protium H2O, that is 18, but DTO it is a 20, and melting point for DTO is 3 degree more, it is 276.8, 3.8 degree more melting point. Okay, and boiling point for water, ordinary water is 373, but 1 degree more for DTO. Okay, this because sometimes question may ask, that's why I told you. Now enthalpy of formation in kilojoule per mole, enthalpy of formation of ordinary water that is a minus 285.9, okay, kilojoule per mole. Enthalpy of fusion, that is 6.01, enthalpy of fusion kilojoule per mole, then it is 6.01. And this density of water is 1 at 25 degree centigrade. Okay, density of water at 298, means 273 plus 25, 298 Kelvin, gram per cc, cc means cubic centimeter, then density is 1 gram per cc at 25 degree centigrade. With temperature, density will vary. Now dielectric constant value, its unit is that is C square, Newton per meter square, and it is 78.39, roughly that we are telling around 80. You can tell 79 also, no problem, but exact is 78.39. And for DTO, same value, very little less, 78.06. There also water just due to the these things neutron in water, neutron is not there. In hydrogen, neutron is not there, but in these things deuterium, one neutron is there, that's why minor change is there. Then dielectric constant value for ordinary, it is 78.39, and for DTO 78.06. Okay, electrical conductivity electrical conductivity is means per ohm per centimeter at 298 Kelvin. Okay, that is a 5.7 into 10 to the power minus 8 per ohm per centimeter. Today I am stopping only here. Next class I will discuss, you can say, more properties of water. Okay, thank you.